Okay, we're going to continue with the law of sines. There's a couple of extra things that are going to come up as we continue on. The first thing we have here is every time you're given a side is an angle, and the angle isn't in between the two sides, there's more at play than just one triangle. You could end up getting one triangle, which is what we get most of the time and what we got yesterday. We could also get no triangles, and we could get two triangles. So we're going to do a couple, and I'll show you how you check to see if you have one triangle, two triangles, and no triangles is going to be real easy to solve, and I'll show you that. So here we go. The first thing I'm going to do, I'm given this triangle XYZ. X is 28, Z is 15, X is 9. So I'm going to draw a triangle. It does not need to necessarily be drawn to scale. I'm going to draw it so it looks like this, I guess. Okay. And I'm going to label this X, and it's 28 degrees. And across from X this is 9. And then I'm going to label this Z, because it appears that this is the longest side. Z is 15. And I'm going to label this Y, and this is going to be a little y. So if we're talking about solving the triangle, we are looking for the other parts that go along with it. So I'll be looking for angle Z, angle Y, and side Y. So the first thing I'm going to do, based on yesterday, is I'm going to do the sine of 28 over 9 equals the sine of Z over 15. And now when I cross multiply and solve this thing, I can cross multiply. Let me get this calculator up here for us. When I cross multiply, I can do the sine of Z will be equal to 15 times the sine of 28 divided by 9. So now when we do that on our calculator, 15 sine 28, make sure your calculator is in degrees. I already checked mine. Divided by 9. And I get 0.78245. So I get the sine of Z equals 0.78245. And now I need to do the inverse sine, the inverse of that. Second sine, second answer will give me that. And I get 51.4. Let's call it 51 and a half. So I get a value of Z is equal to 51.5 degrees. Now, what you need to remember is you need to check to see if there is a second triangle that has a sine of Z of 0.78245 that will fit into this triangle. Remember that sine is positive. The sine is positive in quadrant 1, where everything is positive. The sine is also positive if you remember the STC. The sine is positive in quadrant 2, quadrant 1 and quadrant 2. Therefore, there are numbers from 0 to 36 or 0 to 180, all that have a positive sign. Because of that, and because of the idea of, for example, if you check on your calculator, the sine of 60 degrees and the sine of 120 degrees, what are the answers to the sine of 60 and the sine of 120? They're the same thing. That means that when I do the inverse sine of 0.866, which is square root 3 over 2, I get 60. But how do I know if they mean 60 in quadrant 1 or 60 in quadrant 2? I don't know the difference between that. I don't know which one is going to be which because they're the same. So this means we could have two triangles that are going to make up the possible answers. So let's go back to our thing over here. If I have 51.5 degrees in quadrant 1, which would be like here, 51.5, I could have the corresponding 51.5 over there. So what you do to check to see if there's a second triangle is I'm going to take this value right here and I'm going to do 180 minus it. 180, because here's my 180, minus that 51.5. And when I do 180 minus 51.5, I get 128.5. So I get a value of z over here of 128.5 degrees. Now here's where you figure out whether or not you can have a triangle. The sum of the angles of a triangle have to be 180 degrees. So I have 128.5 degrees. I have x is 28. Can I fit another angle in there, y, that is going to make it to 180? And the answer is yes. These two add up to 156.5, which leaves 23.5 for y. But if I'm over here, let me get this stuff out of the way. This one you just solve how you would normally solve. I have z is 51.5. I have x is 28. I have z is 51.5. And I have y is, if these two add up to 79.5, that's going to leave 100.5. So there are two triangles that satisfy these given conditions, and I have to find them both. So again, what do? Step 1, set up the law of sines with what you have. Cross multiply and solve. This right here, this is where you need to check to see, okay, I know there's two values that are less than 180 that are going to have a sine ratio of 0.78245. One of them is 51.5. The other one is 180 minus 51.5. And now you take your given angle, 28, and check to see. 51.5, 28, obviously I get a third angle. 128.5, 28, I could get a third angle. That's where you determine, can I have another triangle? The only thing left to do here is use the given information. Sine of 28 over 9 equals sine of 100.5 over y. And then over here, I will do sine of 28 over 9, sine of 23.5 over y. There are two different triangles that make this thing go. One of which has a y of whatever this ends up being. We can do that on our calculator. Grab your calculator, do your calculations, and I get 9 times the sine of 100.5. Oh, got too many zeros in there. 9 times the sine of 100.5 divided by sine 28. And I get 18.84. And then I can do the same thing over here for this guy. And I can solve that. And I could edit this thing. But now I'm doing sine of 9 times the sine of 23.5. Goes too fast. Nine times the sine of 23.5 divided by sine 28. 7.64. So when you're solving, you got to check to see if there's a second triangle. And in this case there was. There was 2. Because the sine of down here, where I got it starred, had 2 different triangles. Let's take a look at another one. DEF. First thing I like to do is draw it. I put D here, E here, F here, not drawn to scale. E is 52. E is 5. F is 9er. Did I hear a 9er in there? This will be little d. The first thing I'm going to do is set up sine of 52 degrees over 5 equals sine of f over 9er. Break out the trusty calculator. Do some calculations. Whoa, what happened there? Calculator. 9 sine 52 divided by 5. 9 sine 52 divided by 5. Oops, that's wrong. Jeez. 9 sine 52 parenthesis divided by 5. Very important. And I get 1.418. So I have, after I cross multiply, I get sine of f. After I did this, I got sine of f equals 1.418. Now, let's think about this for a minute. SOHCAHTOA. Sine of any angle is equal to the opposite over the hypotenuse for right triangles. And we're still talking about the same sine here. We're talking about a ratio of an opposite over hypotenuse. I know it's not a right triangle, but this is still where sine comes from. And then we use ratios to solve other missing things. How could the opposite side over the hypotenuse, which is always the largest side, ever be greater than 1? The sine will never be greater than 1. Ever. Ever. So this is going to be a triangle that has no solution. So when I go back here, even if you didn't recognize that, the next step is to take the inverse sine In order to solve for f, I need the f is equal to the inverse sine of 1.418. So I take my calculator and do inverse sine of that answer. And your calculator freaks out at you. It says error, domain. What are domains? It's set of all x's. My x here, what I'm taking the sine of, cannot be greater than 1. So your calculator will tell you if you've made a mistake. Notice the newer versions even remind you, were you supposed to be in radian mode? That's what it's asking here. And we were dealing in degrees, so no. So this is no solution. No solution. No solution. So what we worked on yesterday had one solution. So we've seen 2 solutions and a no solution. The no solution will jump out at you, and one solution isn't bad either. Let's take a look at one more 2 solutions so you can see what's happening. First thing you're going to do, draw a triangle and point out F, G, H. F is 36 degrees, G is 9er, F is 6. And I start by saying the sine of 36 degrees over 6 equals sine of G over 9. And we bust out our trusty calculator, which went away. Where did it go? We'll get her. Bust out my trusty calculator, and this is where we're going to see what we got going on here. So I'm going to do the sine of G is equal to 9 sine 36 over 6. I'm just cross multiplying. So when I do that, 9 sine 36, close the parenthesis, divided by 6. 0.8116. So now I'm going to take the inverse sine of that. And again, that's between 0 and 1, so we're good. I can insert that answer by using second to the negative sign. And there we go. I got 61.84. So I got, let's go with 61.8. Sine of G was 0.883 something. I did the inverse, and G equals 61.8 degrees. This is where we check now. This is the big thing right here. Because I need to come over here and say possible triangle 2. Triangle 2. Possibility. These things are still in play, but I've got this 0.881 it was, in fact. 0.881. So we go back up into that, where I have this guy. And I do that second and that inverse sine of the answer. And I get that thing. And remember, that's the quadrant 1 angle. And every sine has a mirror image in quadrant 2 that also fits in a triangle. And it's 118.15. This was 8.5. Let's go with it. Okay, so this is where you ask yourself, can I have a triangle that has a 118.15 and a 36? And if I add those two things together, I get 154.15, which means H is whatever 180 minus those two things. And it makes it. If these two had added up to more than 180, then I didn't have a second triangle. That's how you can tell. So when I do this subtraction, I get 25.85. There's my three angles of my triangle for triangle 2. Triangle 1, I still have F is 36, I have G is 61.85, and I have H, if I add those together, it's 97.85. 97.85 must leave 82.15. And I have a triangle. So I have two triangles here. I already have G and F. The only thing left to do is to solve for little h over here and little h over here. And that's how we have multiple triangles. So for this one to solve for little h, I would have, which is up here, I could use the sine of 36 over 6 equals, again, use the givens whenever you can, 36 and 6 equals sine of 82.15 over h. And over here, h is going to be different. It's going to be sine of 36 over 6 equals sine of 82. Whoops. Now h has changed. Sine of 25.85 over h. Cross multiply and solve, and you have your two answers. So the moral of the story is when you're given these side-side angles, if this is less than 90 degrees, you're going to need to check for another triangle. If it's greater than 90 degrees, there's only one triangle it can have because you're already into quadrant 2. And now you should be able to work on your homework. It's going to be okay.